Hello, my name is Oh Junjie. Today I want to talk about the Cauchy-Schwarz inequality. These are the contents we want to talk. Now want to talk the introduction. Next is theorem and the proof of the theorem. Then is examples and applications. Finally is talk about the summary. Now we move on the introduction. Cauchy-Schwarz inequality, or the developer are Augustin Louis Cauchy and Hermann Schwarz. Augustin Louis Cauchy was a French mathematician, engineer, and physicist, and he made the contributions to several branches of mathematics. He was one of the first to state and rigorously prove theorems of calculus. And Hermann Schwarz was a German mathematician known for his work in complex analysis. Cauchy-Schwarz inequality is also called Cauchy-Bunyakovsky-Schwarz inequality. It's considered one of the most important and widely used inequalities in different applications of modern mathematics, such as probability and statistics, and complex analysis, numerical analysis, and so on. Now we move on the theorem of Cauchy-Schwarz inequality. Let U and V be arbitrary vectors in an inner product space over the scalar field. Then the absolute value of inner product of U and V is less than equal than the norm of U multiply the norm of V. The absolute value of inner product of U and V is equal to the sum of Ui Vi from I equals to 1 to n. And the norm of U is equal to the square root of the sum Ui squared from I equals to 1 to n. Now we move on the proof of the theorem. Proof 1 is we can divide by two cases. Case 1 is if U equals to 0 or V equals to 0, then the inner product of U and V is equals to 0. Because 0 multiplied by any number is also 0. And the norm of U or V is equals to 0. So Cauchy-Schwarz is an equality. And case 2, if U and V is not equals to 0, we can define a function is ft equals the norm of tu plus v squared. The function should be larger and equal than 0. And the expression can also be written as the inner product of tu plus v and tu plus v. So my expansion should be t squared times the inner product of u and u plus 2t times the inner product of u and v plus the inner product of v and v. So this is a quadratic function in T. Then we solve ft equals to 0. We use the quadratic formula b squared minus 4ac. We let a equals to inner product of u and u, and b is equals to 2 times the inner product of u and v, and the c is the inner product of v and v. Then compute that should be less than equals to 0. So should be 4 times absolute value of the inner product uv squared less than equals than the 4 times the norm of u squared times the norm of v squared. So we can prove that the absolute value of the inner product of u and v is less and equal than the norm of u times the norm of v. the proof 2, we can obtain that the angle to orthogonality is the vector of u times the vector of v equals to the norm of u times the norm of v times cosine theta. By extension, we can refer back to the theorem there. Also can written as the sigma form. Next, multiply both sides by square. We get the sum of ui vi from I equals to 1 to n square and cancel the square roots of the sum of ui square and vi square times cosine theta square. By cosine graph, we know that cosine is between two -1 and 1, and cosine square is between 0 and 1. And we substitute 1 to the equation, we need to change the equal sign to less than equal sign. Then multiply both sides by square root. We can know that the Cauchy-Schwarz inequality is proved. Let x equals the vector of 1, -2, and 4, and y is equal to the vector of 2, 4, -2, the two vectors in R2. Determine the Cauchy-Schwarz inequality to be proved. By formula, we note that the theorem already. So from left-hand side, we can compute that 1 times 2 plus -2 times 4 plus 4 times -2, and with the absolute value will get 14. From right-hand side, we need to compute that the norm of x and y. The norm of x is equal to the square root of 1 square plus 2 square plus 4 square is equals to the square root of 21. And the norm of y is also similar, so compute that is the square root of 24. So compute right-hand side, we get the square root of 504 is equals to 22.44. So left-hand side is less than equal than right-hand side. Now we look at the summary. Cauchy-Schwarz inequality is not just used in a product, also can use in integrals, linear functional, and so on, such as integrals is the integral of fx times gx dx that is less than equals than the integral of fx squared dx times the integral of gx squared dx. And linear functional is also same, is L h1 h2 square is less than equals the L h1 square times L h2 square. So thanks for my presentation.